Sherman+Reilly is introducing a revolutionary new product into the stringing industry. Finite element analysis is part of the foundation on which it is designed and built. Our customers should take note that finite element analysis not only allows us to produce higher quality products now and in the future, but it provides good insight into some of our legacy and historic products to ensure they too are still meeting our quality standards.
I'm John Morton. I'm working here at Sherman+Reilly as a lead engineer. And now I'm working really more in the new product development area, and we are designing the BBK. It was kind of the first part of this year, it was identified that we had somewhat of a gap in our product line. And that gap was that we didn't have an offering for very budget conscious utilities. And it has been kind of the main focus of our engineering department for the past 6 months or so, and it's been a really cool project so far. One of the really important jobs of engineering is the fact that we have a responsibility to the general public to make good designs. And finite element analysis is a really cool tool it somewhat automates that process. There's a lot of human intervention in the setup of it, defining load cases and defining materials and defining how all of those components fit together and are, be it welded together, bolted together. All of that goes into it and is set up by we, the engineers. And then the software outputs essentially a strain matrix and then converts that to a stress matrix.
My name is Daniel Landgraf, and I'm a mechanical engineer here at Sherman+Reilly. My role at this company is to provide finite element analysis results to our design engineers to help them design and produce quality products for our customers. Finite element analysis is taking a geometry and breaking it into smaller, discrete volumes. These smaller volumes can be computed for stiffness, and this stiffness is then used to measure displacements based on the boundary conditions applied by the engineering analyst. Secondary calculations can then take those results and output stress and strain calculations for the model. Finite element analysis, which is validated via mechanical testing methods, gives us meaningful insight into the strength of a design, and with appropriate knowledge of materials, it allows us to better understand the durability of our products throughout their lifetime.
So even before we were making the first prototype, we had input from weld shop, input from machine shop, input from assemblers, and that has it's influenced our design, and it has made the first prototype, in my opinion, go a whole lot better because they're out there building, and it was a group effort even building it, but they're out there building a machine that they know about and that they have had design input into. So we grabbed our kind of core design team and began turning the requirements and ideas and goals that we outlined in the product meeting into reality. So start with 3D models of all of our components. We do analysis on those. We do fit studies, tolerance stack-ups, and most importantly, we build prototypes.
The biggest advantage of using finite element analysis as a computerized tool is to solve complex problems. Solving these complex problems using finite element analysis allows us to reproduce realistic and accurate results of real-world application. This is a very powerful tool for the designing engineer.
We end up through the FEA process with a full 3D model of the stress in the machine under various loading cases. And that it gives us a really high degree of confidence, even when we're building the first prototype, that prototype is not going to have some sort of unexpected failure.